Hello everyone, welcome back to another video. And in this video, we're going to be taking a look at a very important concept. And more than a concept, this is actually a method to determine the empirical formula of some mystery organic compound that they tell you. And these kind of questions come up in every single exam without fail. I've seen them come up. And as you can see, they are worth a lot of marks. 3 marks for one question. That is very rare to see in the IB chemistry exams. But that tells you how important this is because this is a very important concept which can lead you to get good marks. So I'm going to teach you how to do it step by step, how to approach such questions, even though questions are never repeated in the IB exams, but the concept behind them is always the same. So if you understand the concept, then you can apply it to anywhere and you can solve any question. So let's get into it. And by the way, this is from November 2018, and this is paper 2, as you can probably tell. So an organic compound containing carbon, hydrogen, and oxygen has 62.02% carbon and 10.43% hydrogen by mass. And notice how they have not told us the percentage of oxygen. And that's simply because we can calculate the percentage of oxygen by doing this. So 100 minus 62.02 plus 10.43, because we know the percentages and percentages are always out of 100. So if we know the percentage of carbon and hydrogen, we can automatically find out the percentage of oxygen, which is the remaining percentage. And this would give us 27.55, I believe, percent of oxygen. Anyways, now that we have got the percentages of each substance in this organic compound, now we don't know what this organic compound is. We don't know what its formula is, but that's what we're going to try and find out, the empirical formula. That's what we're going to try and get. So the very first step that you need to do is you need to calculate the amount of moles of carbon, hydrogen, and oxygen in this substance. And you may be thinking right now, okay, if you want to calculate the moles of carbon, hydrogen, and oxygen, the formula to calculate moles is equal to m, which is the mass of the substance in grams, divided by the molar mass of the substance. But we don't know what the mass of the substance in grams is. That's not given to us. We are only given percentages over here. So how do we get the mass in grams? Well, all you have to do is that you have to assume, just make the assumption that the compound that they have given you is of 100 grams. So the overall mass of the compound that you have is 100 grams. So if they've told you that 62.02% of that 100 grams is carbon, then automatically the mass of carbon has become 62.02 grams, right? And if you want to find out the number of moles of carbon in the substance, we just have to divide it by its molar mass, which is 12.01. And you can find this in your data booklet, obviously. So, oops, sorry. And this will give us an answer of 5.16 moles. So we have 5.16 moles of carbon. Let's calculate the number of moles for hydrogen. Exact same thing. We have 10.43% of hydrogen, and the overall the mass of the compound that we have is 100 grams. So 10.43% of 100 grams is just 10.43 grams. We divide it by the molar mass of hydrogen, which is 1.01. And this gives us an answer of 10.32 moles of hydrogen. I'm going to shift this over here to avoid any confusion. Anyways, next, let's calculate the number of moles for oxygen. So oxygen, we have been told that there's 27.55% of oxygen in the organic compound, and we have made the assumption that we have 100 grams of the organic compound. So automatically oxygen will, the weight of or the mass of oxygen in 100 grams of the substance will be 27.55 grams. And we divide that by the molar mass of oxygen, which is 16, and we get an answer of 1.721 moles. Now, okay, we have calculated the moles for each substance, the amount of moles for each substance present in 100 grams of this organic compound. So we have 5.16 moles of carbon, we have 10.32 moles of hydrogen, and we have 1.721 moles of oxygen. Now, what do we do? The next step in this procedure is that we have to identify which substance is in the smallest quantity in terms of moles. And as you can probably tell, oxygen over here is in the smallest quantity in the amount of moles. Carbon has 5.16 moles, hydrogen has 10.32 moles, which is the largest, but oxygen only has 1.721 moles. So it's the smallest, or in the organic compound, it exists in the smallest quantity out of the other two, or sorry, out of the three. So what do we do with this information? Well, after we have identified the substance which is in the smallest quantity, we take its number of moles and we divide the other number of moles by the number of moles of the substance which is in the smallest quantity. So what I mean by that is we divide 5.16 by 1.721, we divide 10.32 by 1.721, and of course we divide 1.721 by 1.721, which is just 1. But the answer to this is 3. It's approximately 3. You'll get, if you put this into a calculator, you'll get something like 2.99. So we round it up, we round it to 3. For this, you get an answer of approximately 6. And for this, obviously, it's going to be 1. And these numbers are nothing but ratios, right? These are just ratios. This is the ratio of carbon to oxygen. This is the ratio of carbon to oxygen. This is the ratio of hydrogen to oxygen, and this is just the ratio of, well, oxygen to oxygen, which is just 1. So once we get these ratios, these numbers are actually also going to be the empirical formula of this compound. So this substance is actually going to have an empirical formula of C3H6, notice, and just O, one oxygen. So C3H6O. Now, of course, I'm not writing the one down here because we don't do that in chemistry, but it really, that's, you can just imagine that it is there. This is how we determine the empirical formula. So this whole thing over here is actually the empirical formula of our mystery substance over here. And like you see, they've told us to show your working. So all this working that I have done over here, these are the steps in order to determine the empirical formula. And I hope that you've not lost me, because I understand that in the last part where I asked you to divide the number of moles of each substance by the number of moles of the substance which is in the lowest quantity, you may have been a bit confused. But just remember, identify the substance which has the least number of moles. In our case, this was oxygen with only 1.721 moles, and divide the other substances, the other moles of the other substances by this. And of course, you have to also divide it by itself, which is just 1. That is it. That is it. That's so simple. Anybody can do this. You also have an access to a calculator. You just have to make sure that you get the right steps and you pay attention to them as well. And you have 3 marks in the bag. So just to summarize, I'm going to erase all of this and I'm going to just give it to you step by step once again so that you have understood it properly. And hopefully you can remember it as well in the exam. Let me just erase all of this. Okay, so the first step, when you encounter such a question, write down the percentages of each substance. So like in the question, we weren't given the percentage of oxygen, so we had to find out the percentage. So find out the percentage of each substance. Sorry, I think the element would be better, each element in the compound. And of course, this step should be fairly simple because they would usually give you the percentages of two of the elements, and they will, maybe you have to find out the percentage of the third element like we did. Maybe they'll give that to you, but just this is the first step that you have to follow. The second step is assume you have 100 grams of the mystery organic compound. I'm very sorry for my handwriting. So just assume you have 100 grams of the mystery organic compound. 3, find out the mass of each element in 100 grams of the organic compound, like we did in this question. So I assumed that we had 100 grams, and I found out the mass of carbon because 62.02% of 100 grams is 62.02%. You can see why we use 100 grams. It's just very simple to use. And we did the same for hydrogen by 10.43, and we used the same for oxygen. Oxygen had 27.55%. So that's it. Once you have found the mass, calculate the number of moles. Calculate the number of moles of each element. Remember, each element in 100 grams of the substance. So by this, what I mean is that you have to calculate the number of moles based on the masses that are present in 100 grams. So if you have found out that carbon is 62.02%, or the percentage of carbon in 100 grams is 62.02%, then that would mean that the mass of carbon in that substance is 62.02 grams. And you can use that to find the number of moles of each element in 100 grams of that substance, right? And the next step, I'm going to have to, oops, I don't have enough space over here. So the next step would be, I'm going to have to squeeze this in, to determine which has the smallest amount of moles. And after that, so determine which substance has the, oops, determine which substance has the least number of moles. And sixth step, last step, is to divide the number of moles of each element by the number of moles of the smallest or the least number of moles that is present in the organic compound. And I showed you how to do that earlier. And once you have divided that and you have got your numbers, the ratios, then you can use that to construct your empirical formula again, as I showed you. So if you divide the mass, or if you divide the number of moles of carbon by oxygen, we got the number as 3. And that would mean that the organic compound has 3 carbons, so it would be C3. And for hydrogen, we got 6, as you saw earlier, so it would be H6. And for oxygen, obviously, it was just 1, so it was just O. So that is your 6 steps to find out the empirical formula of any substance when you arrive or when you approach such a question. Thank you so much for watching. I hope that I have been of help to you. I understand that this concept is a bit tricky to understand, But once you practice and you get a hang of it, it's extremely simple. So if you have any questions about this concept or any other concept, please feel free to message me on my social media or any other platform, including YouTube. You can put it down in the comments below, or you can send me an email, and I'll be more than happy to help you. Take care, everybody. I'll see you in another video with another question.